Consider a bank system. Over here, we have an ACID database transaction. An ACID full form stands for atomicity, consistency, isolation, and durability. So, by atomicity, we mean that your transaction will either follow through completely or it will not follow at all. So, it is an all or nothing kind of transaction. Consistency means that you never report during that you never generate a report during an atomic operation. You show consistent output. So if we have something like a write operation happening, like someone is trying to write something, then you will not generate a report that has something to read from the database, because you might miss out on the new things that are being added. So you either follow through or you don't. That's like atomicity and consistency go hand in hand. Then we have isolation. So no transaction should know any information about the other transactions. So if I am writing something, we should not be reasoning to the other node that you should not read right now because something is being written right now. Durability is that you have all aspects of the transactions that are complete and they are permanent. So 50 to 60% of all your code base, if it uses ACID system, will handle these rules. So new databases that are generated by users don't generally support database level transaction management in the first release, but they eventually get to doing this. And why this is important is because it allows you to resource lock, like resource locking. So this means that you can integrate your data by temporarily blocking to stay consistent, and it's a reasonable compromise. In contrast, base stands for basic availability soft state. And over here, by basic availability, we mean that your information and service capability are there. So your report can be generated at any time, even if you're writing right now. And your soft state is that inaccuracy is temporarily allowed. So even if your report is not completely correct, your data might change. But in order to reduce the amount of consumed resources so that no resource is locked for any particular node, you will still allow your inaccuracy to happen. This eventually is updated to avoid the inconsistency. So there is an eventual consistency stage, and that happens after all the service logic is executed and the system becomes consistent again. And an example of this is that your shopping cart in a mobile application that you use will we can compromise on not showing you some application GUI like a loading sign if you have made a payment, and your payment has to go through because it's a more priority process. So it will show you that the payment has gone through after it has actually received a yes from the bank. And your shopping cart on your phone might be showing you that it has not been sent, but it will have sent. So you will eventually get to that consistency stage, but it takes some time to do that. So acid, in comparison to base, provides consistency, and it is pessimistic because it says that anything can go wrong. So we will provide detailed testing and failure analysis of everything, and we will allow a node to resource lock, like lock a resource it tries to use. Base is going to provide you availability for all the nodes. It is simpler and faster because you don't have to write code about the resource locking, but reports might be inconsistent for a while because it is optimistic way of working. It focuses on the throughput, like you will get some kind of response in little time, but it never blocks a write, and it avoids the locking stage. An example of a strategy, a language that uses base is NoSQL, because it allows you to have horizontal scalability through database sharding, and that generally means that you increase the capacity of your database by connecting multiple hardware and software systems, and you do this by sharding. So if your number of servers grows higher, you will like number of data points grows higher, you can divide your data set into different segments and store it on different servers. So this creates like one kind of situation where the number of servers keep on growing. So there is a chance that one might break. So you have to keep on creating data backups and replications. And really, RDBMS has automatic sharding. So it's like splits the large data set into clusters of multiple machines on its own. Now, we can look at the types of NoSQL data stores, like the data storage possible with NoSQL. And there are four main types. One is a document store, one is a key value store, one is wide column, and the last is a graph. So a document store is like it focuses on how to store the data in a format that is like SQL format. It allows you to store the data in a hierarchical data structure. So you basically search the value that you want in a type of document search. You have a wide column storage possibility as well. Here you have a sparse matrix that allows you to use rows and columns as key. And you get an example of this is Bigtable or HBase. You can have graph databases that have relationship intensive problems like social networks or some gene network, and they use nodes, edges, and properties as the primary elements. It allows queries, but it has a different underlying infrastructure. Example of this is Neo4j. Another point for wide column stores is that it is slightly different from RDBMS because it like wide column store can allow each row to have a different set of columns, but the common set of the column group will remain the consistent. Like it will remain consistent. The last type of data storage is key value storage. It is very specific, it is simple, it is fast, and it allows you to store data as a key and value. For example, an image storage, where you can store image itself as a binary value, and the name of the image can be the key. So over here, you can access the value using only the key. You are not allowed to query the value because the value itself is a blob of data. It is very scalable because it has fast retrieval of values regardless of the number of items in the storage. There is no need to specify the type of the value. It can be a blob. The application can determine the type of the data and what to do with it. And the key itself can be many things. For example, I gave the name of the image. It can also be the path name or the file name or whatever. There are two rules to store the key value. It's like first is the keys should always be distinct. So we can never have two items with the same key. Second, queries can only happen on the key and not the value.